Welcome to this second three-part video series looking at more advanced registration concepts in Leica Cyclone. You can download the Cyclone database used in this video series by clicking on the link in the video description. In this tutorial we shall look at how to register the point cloud data to a coordinate system. This process is known as georeferencing. We have seen in our previous tutorials how to register scan worlds together using both target and cloud-based constraints. In the video description you will find a link to those tutorials and to the sample dataset that was supplied. So we're going to pick up where we left off. We run Cyclone and load the church demo dataset. If you have any existing registration from the previous tutorial, delete that, and we're going to re-register these scans. So let's create a new registration. We will add all of the scans at once. Also add our constraints and register the data. Now if we sort by error, we can see that we have a large error at PSS03 in between stations 2 and 9. So I'm going to disable that constraint and register again. You can see that again there's now the biggest error is also between involving scan world 9. So this time it's between scan world 3 and scan world 9. So I'm going to disable that constraint as well and register again. So if we look at the error, we can see that most of the error is in the Z direction. Now there's an explanation for why this target needs to be disabled. PSS03 was accidentally knocked by a member of the public during the scanning process and had to be reset in place and re-leveled. So before we move on to georeferencing our data, I'm just going to have a quick look at the interim results, and we're going to look at one of the targets, PSS02 I think. Now you'll notice straight away that the target height's been applied, so the target's vertex is no longer in the centre of the target, it's on the floor directly beneath, hopefully on the nail. But here you can see that we have numerous positions for that vertex, and that's where the scans have been joined, and we've got a slight discrepancy between the scan worlds. So if we measure, for example, between those 2 points, you can see down here it tells you the distance is 3 millimeters. So I'm going to close that. I don't want to save the temporary space, and you can see that at PSS02 we have discrepancies of around the 3 millimeters which was reported. If we were to go ahead now and freeze that registration, create the model space, you'll notice if we open the control space for that registration that we no longer have numerous vertexes for PSS02, even though it was scanned in multiple scan worlds. This is because when you freeze the registration it will create a single meaned position for that target. So if we close our control space and open our model space view, now the data is correctly registered. You would normally check that with the limit box, but I just wanted to show you a quick way of verifying that the data's registered. You can click a point and go to Tools, Quick Slice, and Cyclone will automatically create that slice view, and then you would colorize the scans individually and go in and check that the alignment is correct. So we can turn that off. Now in our previous tutorial we discussed how targets should be ideally situated in a wide triangular formation, and this is true of the targets that we'll use to coordinate the scan data. So the target should be ideally placed with a large aspect ratio such as a large non-equilateral triangle or a wide rectangle. And what we can see here is that we've got PSS1, 4 and 3 form a really big triangle, and we've also got PSS2 here. You can register with just 3 targets. Depending on the size of your job, we'd always recommend to use some redundant targets. So in our data sets, the surveyor in the field has recorded the target ID, and the height of the target has also been established. In our case, the survey control points were levelled and coordinated to a local grid using a total station. And looking at our registered data set, yeah, we've got those 4 points established in a good geometry. And close that window now and look at the control file. So if we pop open File Explorer, we can see our control points text file. We can see we've got target ID, easting, northing and height. And we can see that the data is comma separated. Now your control point file could also be tab separated or space separated. If we copy that file path, switch back to Cyclone, and we can import the control file. And you can see that here we've got some defaults. One's called control format, and that is set up to be comma separated. You could also have semicolon separated, tab or space, or even enter your own definition. Our data's been imported in meters, but if you're working in the US, you might want to change that to feet. And you can see here that the columns are labelled target ID, easting, northing and height. So that's all going to import correctly. So we'll go ahead and do that. So just as a brief aside, should you be working in feet or other different units, go to Edit Preferences and change the units to feet. So I'll just show you where that is, Edit Preferences, and under linear units here you can choose which units you'd like to use. If we open the control space, you'll see the 4 targets in their positions. So we've registered this data, but we would like to unregister it and add the control in. So if we delete the model space, we can then reopen the registration and say registration, unfreeze registration. Now we can add in our control points. And this is treated as a scan weld, just like any other. So we'll right click on that, and we're actually going to make this our home scan weld. That means that all the other scans will be registered onto the coordinates contained in this scan weld. So we'll say auto add constraints, and this time we're going to sort by scan weld. As you can see, we've got some crazy residuals, so we just need to register that data. Excellent, and you can see that we've got very good fit. You'll also remember that we disabled PSS03 in scan weld 9, so we're going to disable that target, which actually has an error of 5 mil. And again, you can see it's almost all in height where the target was knocked. So we'll disable that one and register. And now if we sort by error, we can see that our worst error is just 6 mil at this one target here, L3. All the other targets are 4 millimeters or better. So now if we create the scan weld and open the model space, so I just create the model space this way and open the model space. We'll be able to see that the coordinates have changed. You'll see now it's on a much larger coordinate system. And if we orient our data, you'll see that we're now on the local grid for the church. So the long edge of the building is aligned horizontally. And that's useful later when you're drawing your elevations or sections, because you can use these preset views to help you draw those elevations. If I just make that limit box a bit thinner, then you can see how that could work. I would usually export the data to a recap file and then bring it into AutoCAD to draw an elevation. However, you can take a high resolution screenshot and do the tracing from the image export in AutoCAD, but that will be the subject of a separate tutorial. So we could rename our registration now to registration coordinated. Now there is another way to register data onto a control, and this is called a nested registration. So I'm going to show you that now. Once again, we're going to delete our model space, and we're going to go back into the registration, and we're going to unfreeze this registration. What we're going to do is remove the control point scan world and just register with scan world 1 as the home scan world. So this is back onto an arbitrary control system. So we're going to call that registration local. And just to show you, if we open up, sometimes Cyclone throws up these messages, you can ignore that one. Just try again, it will work. Now if we pick a point, you can see that we've got nonsensical coordinates just based on the 0, 0 point of scan mode 1. So to perform a nested registration, we can create a new registration, and we can add in scan world local that we just made and the control points. We can set the control points as the home scan world. We can auto add the constraints and hit register. The difference with a nested registration is that the control file is not having any effect on how the scans are registered together, because the imported registration is fixed, or in Cyclone terminology, frozen. With a nested registration, we're transforming our combined scan world onto the control points. A nested registration acts as a good check on how well registered your data is. For example, if you know that your control is very accurate, then any errors could be due to poor registration. Conversely, if you know that your registration is very tight and you see errors, then this could indicate a bad control file. Join us in part 2, where we'll be looking at using scan world groups. If you found this video useful, please don't forget to hit like, share and subscribe. Thank you for watching.